So it's my pleasure to introduce Dr. Anastasia Kuzminykh, an assistant professor at the University of Toronto in the Faculty of Information, cross-appointed with the Department of Computer Science. She's a member of the Data Science Institute, a faculty affiliate with the Schwartz-Reisman Institute for Technology and Society, the director of the Toronto Human AI Interaction Research School, and the director of the Cookie AI Research Group. Her work is situated at the intersection of AI agent design, explainable AI, AI safety, natural language processing, and conversational interface design, touching on diverse technologies, including LLMs, generative AI systems, and AI-based decision support systems to advance our knowledge on different facets of human AI communication. So please, Dr. Kuzminykh, please take it away.
Thank you so much, Chris. So hello, everyone. Thank you so much for inviting me. So today I'm going to talk to you about the role of collaborative communication between humans and AI. So as Chris mentioned, my name is Anastasia Kuzminykh, and I'm currently an assistant professor at the University of Toronto, Faculty of Information, cross-appointed with the Department of Computer Science. And although my PhD is in CS, and for the last many years, I'm an HCI and systems design researcher. Before that, I worked in anthropology and then cognitive psychology and neuroscience. And I was always interested in communication processes. And over time, I became interested in this notion of humans and technical systems as communicative entities. And now at the University of Toronto, I lead the research group called COOKIE, which stands for Communication, Organization of Knowledge, and Information Ecosystems. And in our work, the overarching goal is to develop an efficient collaboration between humans and AI. So with time, I became fascinated by this idea that you've got two really intelligent, powerful entities, a human and AI. And what we're trying to do, we're trying to put them together to make them communicate so that they can accomplish a richer set of tasks and optimize what each is capable of. And yet developing this communication keeps being surprisingly challenging. So on the one hand, it becomes more and more clear that our ability to create a partnership between humans and AI systems is going to define what we as a society are going to be able to accomplish. On the other hand, this partnership and the success of this collaboration is predicated upon building effective and efficient communication between users and AI systems. But developing such communication is pretty tricky. And to demonstrate why, let's first look at the differences between classical interaction and actual communication. So while both involve information sharing and more than one party, there are some important differences between these processes. In classical, conventional interaction, we have our interacting parties, so let's say a human and a machine, and for a defined input from a human, such as pressing a button, there is a defined outcome from a machine. This is the way how most classical user interfaces that we all are used to work in a nutshell. And interaction can be happening in any modality, pressing a button, shaking your phone, I don't know, making a gesture, typing a command. And similarly, same goes for simple conversational user interfaces or GUIs. Straightforward conversational input, something like Alexa, tell me the weather, straightforward out, verbal, visual, or whatever other modality the system uses. But this is not yet communication per se. So how does communication differ? You can consider communication as a special case of interaction. And as a subtype of interaction, it again involves minimum two parties. Let's use the same human and a machine as example. But now there is a perceived agency on the receiving side. So what is this perceiving agency? This is this perceived capacity of entities, in this case AI, to act independently and to make their own free choices. What does this agency change? Now we, as users, start trying to affect these independent choices on the receiving side, right? On the perceiving side, on the AI side. And as humans, we best know how to do that with other humans. So we start mindlessly anthropomorphize this system, start assigning it separate human-like qualities to help us interpret and predict how the system would understand us. With classical human system interaction, when I press a button, I don't need to think whether the system might think I'm angry or supportive or in a rush. I would expect the same outcome every time. So let's say I press a button, the light goes off. Within communication, due to this perceived agency on the receiving side, I can expect variations in interpretation of my action. And so for a given input, the output might significantly vary. So now within communication, the entity on the left, so our user, would start changing different properties of their input, trying to adapt, trying to affect the interpretation. And the encoded meaning of this input suddenly becomes contextually dependent. So as a user, I will be giving input in one way in one context and in a different way in a different context. And if we want this process to be bidirectional, as in most cases of true communication, the system's output should be synthesized correspondingly, so depending on a contextual meaning of the user's input. And of course, communication might happen in different modalities. However, conversation, so our verbal language, is one of the most intuitive and common modes of communication. So at least at this stage, we as an academic academic community, a scientific community, predominantly focus on language, at least as input modality in communication. So why is this difference particularly important in the development of human-AI collaboration? Well, because it allows us to finally start shifting from purely using a machine as a tool to working together with it towards a common goal. So from pure interaction, from telling the system what exactly it needs to do, to human-system communication, to working together with it on a common task. For example, instead of telling the system to label a piece of data as X, I would tell it something like, we need to figure out the best label for this piece of data. And this working together with the system towards a common goal is basically what true collaboration is in its essence. So while there is still a lot to learn on how to build AI systems so that this collaboration, this partnership between humans and AI can actually work in our favor and to its true potential, it's rather clear that the success of human-AI collaboration is predicated upon building AI systems that are first producing what we actually need them to produce, so they're reliable. And what's particularly important, we can appropriately trust their outcomes. And appropriately here means that we trust system according to its performance, so that we do not over-trust or under-trust the system. Second, the systems should be communicative, so we need to be able to understand what they produce, and they need to be able to understand what we want from them. And finally, they need to be useful in a sense that we humans should be able to effectively incorporate what they produce and ideally avoid any unwanted societal consequences. So what is the role of human-AI communication in ensuring all of this for the system? So first, since communication is contextually defined, its interpretation is different in different contexts. It means that the system should be able to produce outcomes that are reliably relevant to these different contexts. For example, if I ask the system to write a passage, it needs to understand that writing a passage for a school essay and writing a passage for a social media post, for example, requires, let's say, different writing styles. And it should produce outputs accordingly. This is achieved, for example, through the algorithmic design of AI models and different approaches to their training. Second, given that the human input becomes context-dependent and varies in many of its properties, such as structure of user prompts, nuances in vocabulary that users use, and so on, significant effort is directed towards decoding these variations. in human input, which is crucial for the system to properly follow users' prompts and to interpret their communicative input, which contributes, of course, to our ability to develop systems that understand us. Now, the mechanisms that define these variations in user input and what human users are actually saying are heavily dependent on the user's mental model. So the user's understanding of the system. And knowing these dependencies between user mental model and how they formulate their input is needed, again, to support appropriate decoding of communicative input. What exactly does the user mean? The user's mental model, the user's understanding of the system, is influenced by many factors, of course, and it's different for different user groups. So mental models of domain experts would differ from those of naive users and would also depend on different social and cultural backgrounds and so on. Furthermore, they are affected by common knowledge about AI systems and societal perceptions, which often come from public media, for instance, and different predispositions, and all of which affect our trust dynamics and our idea of how reliable the system is. Because no matter what, no matter how well this system actually performs, if we're predispositioned not to trust it, its actual performance wouldn't matter, and the other way around. And of course, mental models and user perceptions are heavily affected during the human-system communication itself. And here, these user perceptions are affected by the system's output. For example, how the system speaks or what it shows to the user. So correspondingly, research on this relationship informs the synthesis of the system's output. And again, there is a myriad of nuances here, from the sentence structure to the speed, to using different types of addressing and referring to objects in the discussion. So understanding how to synthesize and format the system's output contributes to both the system's perceived reliability and to its communicativeness, so how the system should talk to us as users. Finally, all these processes, of course, influence different aspects of the task performance and task outcomes. And unsurprisingly, understanding how it happens is needed to develop useful systems so that we can effectively use what AI produces while considering the corresponding societal consequences. In our group, in the Cookie group, we explore all these elements, but as you can imagine, there is quite a lot to discuss here. So today, I'll give you a brief dive into the role and place of communication in human-AI collaboration by first talking about how the architecture of the system's output, what and how system communicates to us, affects users' perceptions. Then I'll talk about what we learn on the ways users formulate their communicative input to the AI system. And finally, I'll give examples of our work on the effects of communication on human-AI collaborative tasks. So in exploring how the architecture of the system's output affects users' perceptions, we particularly focus on verbal output, both in text and voice. For instance, we're exploring the opportunities to use speech variations as trust calibration technique for voice-enabled prediction models, or for example, we explored the effects of the structure of verbal AI explanations on the user's interpretation of the information, how trustworthy it is, how reliable it is, or the effects of AI explanation structure on the perceived fairness of decisions in financial models. But I would like to particularly highlight here one of our recently published projects, which was done in collaboration with young Colloquium from Neighbor AI Lab. So as users interact with conversational intelligent agents, they form different perception of this agent, such as whether it's intelligent or likable. And since these agents communicate using natural language, one of the key factors shaping this user's perceptions is what the agent says and how it says it. So it's conversational architecture. While these connections are somewhat explored in literature, there is a lack of systematic understanding of how conversation architecture affects different perceptions. So how do I need to synthesize the agent's speech if I want it to be perceived in one or another way? So with that, what we wanted to do in this project, first, we wanted to understand what are the perceptions of the agent that are affected by conversational architecture. Then we wanted to see what elements of conversation actually affect these perceptions. And finally, what is known about the specifics of the relationship between these two. So what perceptions are affected, what affects these perceptions, and what are the relationships? To answer these questions, we decided to synthesize first what is known in these effects of conversational architecture from previous research, and we conducted a systematic literature review of the work published between 2010 and 2022. So what did we find? Let's discuss some of the highlights of our findings. So to answer the first research question, what are the perceptions of agents affected by conversation architecture? We found 4 categories of these perceptions. The first category assesses the overall interaction quality between users and conversational agents, including aspects of usability, engagement, which is users' emotional reaction to the interaction with the agent, and user satisfaction. Perceptions of agent's ability refers to the perceived capabilities of an agent with the tasks that require intelligence. So that would include intelligence itself, expertise and knowledge, competence, so how this intelligence is put into practice, and credibility of an agent. So this captures the perceived truthfulness, benevolence, and users' confidence in the agent. The third category was the sociability, which is the emotional connection that user have with the agent, which includes conversation tone, social presence, the perceived intimacy with the agent. And finally, perception of agent's humanness. So this includes human likeness, how human-like the agent is, and the personality traits assigned to it. Now for our second question, what elements of conversation actually affect all these perceptions? We also found 4 categories. And the first one is the dialogue strategy. So this is the approach used by an agent to engage in a dialogue with a user, which includes the use of social dialogue, showing initiative, and response delay. The second one is content effectiveness, which refers to the agent's use of language to convey emotions and to elicit emotions from users, including using effective language and humor. The category of content style refers to the formality of the message, alignment, which is the degree that an agent matches the utterances from the user, and elaborateness, so how complex the sentences are and the length of sentences. And finally, the category of speech format, which is the non-verbal component. Disfluencies, prosody, like pitch and intonation for voice-based agents, text formatting for text-based agents. And so now that we understand more about what perceptions of agents are affected by conversation and what are the elements of conversation that affect this perception, we wanted to know what is known about the specifics of this relationship. And we found that the perception of agents' ability, so intelligence, competence, credibility, have been explored the least in relation to speech variations. And perceptions of interaction with an agent, such as usability, engagement, satisfaction, have been explored the most. Which kind of makes sense because these general perceptions, such as engagement, satisfaction, are probably the easiest ones to explore. But more complex perceptions are arguably more important and deserve more attention. And to demonstrate that, let me briefly talk about another study we did, which was the study on anthropomorphized perceptions of commonly used conversational agents. So intuitively, we know that not all the agents are seen the same. But our understanding of these underlying patterns of these perceptions of agents is rather immature. What we did know about anthropomorphization from before mostly from robotics, is that people differentiate between design of agents' behavior, such as emotional responsiveness, how warm they are in interaction, their personality, and so on, and their physical or visual aspects. So let's say facial and body expressions. Let's say Roomba vacuum has only behavioral anthropomorphic traits, the way it moves. But wax sculptures would have only visual ones, the way they look. And by design, voice assistants are capable of displaying mainly behavioral anthropomorphic aspects. But what behavioral aspects matter to users? Is there any structure there? And we hypothesize that if there is any structure, then these perceptions will be different and consistently different for different agents. And we also hypothesize that the way people perceive this personality and behavior of agents would affect how they visualize that. So how users think these agents would look like if they were humans, especially since an agent's answer might include visual references, such as Siri's, I'd blush if I could. So then, if there are consistent patterns in behavioral perceptions, we can also expect consistent differences in visualizations of agents. And all these questions could only be examined through a comparative analysis. And so we took 3 agents, Alexa, Google Assistant, and Siri. And we first asked participants to interact with agents because we wanted this in situ comparisons. We then conducted interviews asking people what each of these agents would be like if they were humans, what their definitive characteristics would be. And finally, we asked people to create an approximate visual representation of Alexa, Google Assistant, and Siri. So what did we learn? The main highlight regarding the perceptions of agents' character was that they are indeed structured, and they're structured according to 5 categories: approachability, sentiment towards the user, professionalism, intelligence, and individuality. And furthermore, they're indeed different for different agents. So each of these 5 themes represents a comparative scale for an agent's character. For example, the theme of approachability reflects an assessment of how emotionally distant or approachable an agent is. The distance end here includes, for example, an agent being snarky and closed off. And it's often would be in contrast to a user's willingness to engage in closer relationship. For example, a very one-sided relationship, like they didn't want to talk to me, like here's your answer and go away. The approachable side of the scale reflects perceptions of an agent as emotionally warm and friendly and willing to interact with the user, for example, being welcoming, outgoing, feeling more like a friend. The second theme is agents' perceived sentiment towards the user and defined through the dichotomy of genuine versus disingenuous attitudes of an agent. So how trustworthy and how focused they are on a user. The genuine aspect includes descriptions of an agent being benevolent, caring, altruistic, for example, coming from a good place, being patient, accommodating, really trying to help you. And opposing these caring, benevolent perceptions, the disingenuous side reflects assessment of an agent as cunning and indifferent or inconsiderate. For example, descriptions such as sly, pretending, or about Siri uses her sus as a defense mechanism. One more example here, the theme of agent's individuality refers to participants' perceptions of how much character an agent is displaying. So this theme is represented by a dichotomy of neutral versus defined individuality. And the neutral aspects include descriptions that explicitly highlight the ordinaries of an agent character. So shy, not many interests, is just some random kid trying to blend in. And the defined individuality differs for different agents. So for example, Alexa has a glowing personality and Google is warmer but nerdy chill. So the behavioral perceptions are both structured along these 5 dimensions and are different for different agents. What about visualized perceptions? So we first composed users' visualizations into collages and also created a cumulative visualization for each agent by overlaying corresponding avatars. And as you can see, the outcomes are already quite illustrative on the differences between the agents. But we also looked at the verbal descriptions and at the avatars and identified different themes in agent appearance. So some examples here would be age, for instance. There is a trend here that Alexa is generally perceived to be older, while Siri is perceived to be younger. The specifics of facial expression. They often would reflect the perceived approachability of an agent and interestingly show the differences between agents. For example, Google seems stressed. They've got a lot of stuff. Alexa is just maybe a little bit smiling, and Siri would be smiling a lot and has a lot of energy. The clothing style, that was the fun one, was heavily dependent on the personality of an agent. So for Siri, for example, the clothing would revolve around daring personality with highlighted femininity. So she would be wearing heels, miniskirts, crop tops. Google clothes are associated mainly with stereotypically awkward personas, like wearing weird skirts. And Alexa clothes would reflect her caring and cozy nature, like pullovers, big sweaters, or wearing mom jeans. So with that, both behavioral and visual perceptions of conversational agents seem to have this consistent structure. But what's more important for us, we wanted to understand what design elements of these agents affect each of those perceptions. And so we found in this project 3 major categories of these features. First was the category of provided information, including the amount of information and the level of detail. For example, they give more information, so it seems like they care about you understanding what they're saying. Second one was the designed interaction style of an agent, such as responsiveness to prompts or prompting users back. For example, seems closed off because doesn't do any prompts back like how are you and stuff. And the tendency to use jokes. And the third category is this agent's voice characteristics. For example, more enthusiastic, like there is more inflection in her voice, sounds a bit more fun. And all these results also showed how these parameters have different impacts on the behavioral dimensions and visualized perceptions of agents. In the main takeaway from this study is that first, people produce extremely rich, socially meaningful interpretations of the system, which includes users' extreme tendency for displaying biases and social stereotypes. So these anthropomorphized conceptions are very socially and emotionally charged. But the good news is that they are consistently dependent on the particular elements of the system, which gives us a stable gateway to these perceptions as we develop these agents. Now, these were some examples of how systems output structure affects users' perceptions. So let's now move to the second part and look at how users formulate their communicative input to AI systems. Right now, we're mostly focusing on variations in conversational prompt engineering for generative AI systems and conversational data exploration. For example, we looked at cross-modality prompt alignment in AI-assisted art generation. We looked at conversational exploration of documents and so on. And the idea is that, of course, overall, people try to vary their prompts using different strategies depending on what they want to get from the system. So for example, in one of the projects, we looked at the prompts that users, regular users, use for AI art generation and the associated biases. So we looked at what biases do people discuss in association with prompts, and we found that people mostly discuss gender and racial biases, along with economical and political ones. And we looked at what associations do people see with the prompts they use and how they try to vary these prompts. And the first one was that there are a lot of biased outcomes associated with certain job types in prompts, particularly with assertive words. For example, including search terms like CEO exclusively generates images of white passing man in business suits. Second, we found that there are specifically gender biases associated with the use of words like nurse or jobs like nurse or personal assistant. So systems would generate images of women. And lastly, there's some words that have harmful stereotypes associated with them. So one example being the mention of women or the use of feminine language might return suggestive images. And so in this study, we looked at how people adapt their communication, so their prompts to the system to avoid these biases. So how people adapt their communication to affect the system's behavior. But we should also consider, of course, how the system should adapt its behavior to the user's input, because that's the ultimate goal, right? So for this, we need to learn to better understand what people actually mean and want, to better interpret their input. And I want to give you an example here of Nazar Panachevny's work, where he wanted to develop a system that would collaborate with users on developing charts. And he wanted to use natural language interface for the system, but most of the similar current systems tend to prioritize text over voice input. And he wanted to use voice interfaces because they offer more freedom of expression and are generally more accessible for users. So the system would need to be able to recognize what users want, interpret this human's input, and develop something based on it. So first, Nazar examined through a user study the structure of human voice descriptions, voice input for these task creation, chart creation tasks. And then he compared it to the equivalent text descriptions. And he found that voice descriptions have a variety of command formats, element characteristics, complex linguistic features. And the text input would only include some of these elements. And you can see it in red on the slide. While in voice descriptions, people would use iterative commands to perform tasks for each element, refer to the chart elements created earlier, ask the system for advice, correct previously described elements, and so on. So this work showed that the voice authoring input is much more complex, and thus the system with voice interface have to be trained on a specialized voice descriptions dataset. In a similar note with Anshuta Kulkarni, who is a master's student in the lab, we're exploring the differences between how people express different social dynamics, such as demonstrating engagement or applying social protocols in conversations with agents versus other humans. And knowing this difference allows us to better design intent recognition and input interpretation when people communicate with conversational agents, showing that the correct recognition and interpretation of these inputs requires different approaches to training the model. So we cannot take human-human conversation to train the model to recognize intents in human-agent conversations. Finally, the quality of collaboration, of course, depends on how these systems are being incorporated into the task space. And again, here's some projects to showcase to you, including the projects on the perceived ownership of human AI co-creations, or the effects of this human AI communication on the learner performance in education space. But I would like to particularly focus on the project by Sharon Ferguson and Paula Aoyagi, both master students, on how, both PhD students, sorry, on how people use AI input in cases that require argumentation for one or another decision. So in this project, we explored human AI collaborative decision-making, specifically focusing on so-called ambiguous scenarios. Ambiguous scenarios are the ones that do not have ground truth underlying them. And the project focused on subtle sexism as an example of such ambiguous scenarios. And this becomes particularly important for content moderation, because most of the sexist moderation right now is based on the use of explicit language, while subtle sexism is much more hidden and its interpretation is context dependent. So the moderation decision is left mostly to humans, and AI support in this case could be used to surface new perspectives while humans make these decisions. And you might notice that the slides will be in a slightly different style because I actually borrowed this from one of the Sharon's and Paula's presentations. So in this project, we first identified subtle sexism scenarios posted on discussion sites online. And we then chose 10 of these scenarios and prompted the GPT model, asking it whether it thinks that this scenario is sexist or not, and was asked to explain it, why it thinks it's sexist or not. And this resulted in 10 text explanations produced by AI. So we then ran a user study where we first asked the participants to read a potentially sexist scenario, and then asked them whether this scenario is sexist or not and why. So they needed to explain their decision in writing. Then we would show them a text explanation from the AI data set for the same scenario, and people knew that it was written by AI, generated by AI. And finally, people were asked to provide their final assessment of the scenario and the explanation for it. So what we found that first, the AI-generated text impacted the language that people used in their explanations. And participants were borrowing terms directly from AI explanation text. For example, on the top here, you can see the initial human-generated explanation. Then the participants saw this text explanation generated by AI. This is kind of thinking that leads to common stereotypes about women. And the final explanation from a human participant, in the final explanation, you can see the word stereotype brought up, but the rest of explanation remains unchanged. In other instances, we noticed that human participants may have been trying to match the level of detail provided in the explanation for their final explanation. So for example, this initial explanation was rather short on detail, but the AI explanation was a lot more detailed. And in response to that, the participant added detail, even though they did not agree with the AI explanation. They did not change their stance. They say, I still think it's a sexist joke, but provide much more detail in the explanation. And lastly, we found that in some instances, the human participants would change their argumentative direction for their final explanation. And this flip happened mostly when people were on the fence in the initial explanation. For example, here in the original explanation starts with, I'm a little bit torn about the scenario. Then the participant saw this AI explanation, which strongly thought it was not sexist. And on the final explanation, the participant agrees with the AI, changing their stance from it depends to it is not sexist. The same could be said about men as well. So this study provided the first early empirical evidence on the influence of AI collaborative input on human rationale in ambiguous scenarios. And unlike objective decision-making, subjective one uses personal decisions, right? So it can benefit from new information and perspectives. And AI can expose different patterns and insights that humans might have missed. And while we found that humans adapt their language after seeing AI explanations, it's evident that people did not blindly follow the stance presented by AI, which is a common concern in discussions about over-reliance and trust calibration. And so while this paper demonstrates some usefulness of the AI assistant, this assistant can also cause some trouble. So for example, in this project, in another project, we examined the use of conversational agents in the financial sector, and we examined 34 chatbots in banking and financial industry. And we found 3 areas where these agents exhibit or reinforce societal biases through the communication patterns, leading to marginalization of some groups of financial workers. So the first one here is the assumption that transactional work performed by customer services is repetitive and can be automated in chatbots. So by automating more of these tasks, it introduces this self-reinforced cycle that confirms these types of work are indeed low value or like should be replaced or something like that. The second aspect here is that chatbots are often concealing human labor behind the machines or these chatbots. So many companies choose to have human agents jump in and handle inquiries that virtual agents are unable to answer. So instead of communicating to the user that this now is going to be a human agent, if these agents are not designed properly, users may not be able to distinguish between communication with a human and communication with an agent, and mistakenly attribute the service worker's labor to the machine. And lastly, these conversational agents are reinforcing stereotypes, such as using typical female names or agents, for example, Erica from Bank of America, as well as some choosing to use a female representation avatar. And these choices may be perpetrating harmful gender stereotypes and attributing subservient attitudes to the female gender to represent customer service employees. Okay, so to summarize, today I try to convince you in the importance of collaborative communication between humans and AI. And I did it first by talking about the effects of the architecture of the system's communicative output on users' perception of the system. And I focused on several projects related specifically to the perception of conversational agents. Then I talked about how users formulate their communicative input into AI systems and how it's important for us to understand to be able to correctly recognize users' contextually dependent intent. And I did it on the example of prompt variations to avoid gender and racial biases and specifics of voice input in comparison to text one. And finally, I briefly talked about how human AI communication is being incorporated into the task space on the examples of the study on human AI collaborative decision-making regarding these ambiguous cases and workers' marginalization in the financial sector. And I'm going to end by bringing again the slide with our sponsors and all the amazing students who drive the research I presented today, and actually many more exciting projects, because without them, none of this work, of course, would be possible. And with that, I would like to thank you for your attention, and I would be happy to take your questions.
All right, thank you, Dr. Kuzminykh, for the nice talk. Okay, do we have any questions? Yes, I'll bring the mic to you. Yeah, I think maybe. Go ahead. Yeah.
Okay, thank you, Dr. Kuzminykh. Really interesting talk. My name is Ziad Kapti. I'm the director of the School of Computer Science. And I wish you came here in person and we had to meet you, but you know this is really good as well. Very interesting talk. I dabble in agents and multi-agents just to kind of start the context, and I've been asked a lot to talk about AI and explainability and some of the issues concerning this. I have a lot of questions, but let me narrow it down. In the last part, where we looked at value of work and low value of work, actually I was reading an article just in a couple of days about a worker that basically got fired because although she met her objectives, her task objectives that are given to her, they looked at the log, the interactions with the computer, with the system, and there was not sufficient keystrokes or interactions, and they didn't really tell what they were looking for, whether it's they're monitoring her eyes, looking at the computer, or whatever it is they're monitoring. So there's a magic black box that basically determined that she has not made the cut in terms of expectations in interactions with that machine, although she met all her objective tasks that were asked for on the high level. And actually that was in the news as a case. And I'm wondering, how does your work help in preventing this overwhelming, where the policymakers or the powers to be in the corporations rely on this information, even though it's useful, insightful, but somehow they make it really serious, and the outcome can impact people's lives. So I'd like to hear your point of view on this, and how can we justify technology versus the outcome of technology when it's not desirable to us?
Thank you so much for the fantastic question. It's a very big one. I'm going to try to give a brief summary of some thoughts on it. So I didn't have a chance to cover it in this talk just due to the time constraints, but we do some work on the algorithmic design side as well. This is what I was trying to highlight when I was discussing how reliable the system should be in a sense of producing what we need them to produce. I guess the question here is to understand who is the user of this system. Right now, when these monitoring systems are designed, the user of the system is perceived to be the boss, let's say, right? The one who is making decisions based on this data. However, the ones who are actually interacting with the system are the workers. So this is where these reliable, communicative, useful bubbles come into play. I don't think that that means we shouldn't, we should say no to the systems in general. I think what we should do, we should try to design them properly so that they can actually give us what we want from them. I'm not familiar with the specific case you were talking about, but there are a lot of similar cases in the world. And typically it comes down to the wrong algorithmic design of the model behind it, right? So not considering the input that is considering the input and making decisions based on this input that do not correspond to the higher level goals of the user in this case. So that is why it's so important to properly communicate to the system what we want from it and for it to communicate to us what it actually means, rather than just output a particular label. I don't know, the number of hours, for instance.
Thank you. I think the key word might be the ethical use of your findings. Absolutely. And how they, use it ethically in their workplaces, and knowing the biases and knowing how they kind of seems to me like they're exploiting the biases to maximize profit, which what the industry does. But the word ethics doesn't occur much anywhere. And that's kind of where the line would need to be drawn somewhere in the minds of people who will take this technology and, I don't want to use possibly misusing it, and unethical use rather of the technology. But no, wonderful to see what you've done. I'm definitely interested in reading your papers and learning more about your work. Thank you.
Thank you. Any other questions? No? No other questions from the audience? All right, let's thank the speaker one more time.